Okay. So, first of all, there are really 3 ways that we're going to be able to do an inverse, okay? So one of them is I want you to be able to, if I give you a table, how do we find the inverse? Okay, so you're going to see there's a table there. The other is going to be, what would it look like on a graph if I found the inverse function? And the third would be, what does the equation look like? Okay, so kind of thinking of those 3 things. The premise of an inverse is it's a relation that maps the output back to the original input or x values. Okay. So, if you're dealing with a table or I guess a list of ordered pairs, like that first one, the x and y values of a relation of the ordered pairs are flipped around to find the inverse, okay? So let's take a look at letter A, for instance. Oh, I should say in a table, you are going to switch the x and y's. So if I want to reverse these, in other words, I want the x to go back to the y's to make it go back, what would happen then is my table where the x values would then move to the y values, and the y values would move to the x values. So I could then take this and flip it around on the inverse. Instead of -2 going to 4, the x would be 4 and the y would be -2. Do you see I just flipped those around? So on this ordered pair, -1, 2, the inverse function would take a 2 and it would bring it back to a -1. So the 2 would go back to -1. So we're just reversing those. What if it was 0, 0? Well, flip those around, it's still 0, 0. Okay, 1 to -2, that would be flipped around, and then it would become -2, 1. And the function and the point to -4 would be -4, 2. Okay. So, do you remember way back when we talked about domain and range? Which one was domain, the x's or the y's? X. So here, this is the domain, and the output is the range, right? What happens on the inverse to those things? So in the domain is -2, -1, 0, 1, and 2. What happens on the inverse? What does that become? Yeah, so instead of the domain of the original function becomes now the range of the other, okay? So the domain of the inverse is the range of the original function, or original relation. Okay. I'll get to the graph part in a second. So when we're dealing with functions, they have to have that each input has exactly only one output, okay? And so this is a function. I have only -2 goes to that. I have only one listed x value. So the question that I have for you then is, we should always check, is the inverse also a function? Because it's not always going to be the same deal if you flip them around. So I check. Do I see another 4 in the x list matched with anything else? No. Do you see another 2 in this x list matched with anything else? Nope. I don't see another 0, another -2 or -4, but just know that that is a possibility. So is the inverse a function? Yes, it's still a function. Okay. Now let's talk about graphs. So if I switch the x and y around, if I want to draw a graph, what that looks like is the graph of a function in its inverse is the reflection. Think back to geometry. Remember reflections, we flip things over, of the original equation about the line y equals x. So there is symmetry around the line y equals x. Okay, so let me show you what I mean. First of all, we're going to take this graph, we're going to list some of the ordered pairs in a second. So what ordered pair would that be? 1, 2, 3, 4, 5, 1, 2, 3, 4. This is the ordered pair -5, 4. 1, 1, 2, 3. This is the ordered pair -1, -3. And this is the ordered pair 1, 2. One, two, three, four, five. Okay. Now, what we're going to do, I'm going to use a different color, is let's see what happens when I switch the x and y's around. And we're going to do 1, 2, 3, all 4 of the points. So if I switch the -5, 4 around, let's switch it around, it becomes 4, -5. Agreed? Okay. Would you plot the point for -5? I'm switching that around. So where did I get that from? That's the inverse of this point. -5, 4 flipped around is 4, -5. All right, let's move to the next point. -1, -3. On the inverse, reverse that. That would be -3, -1. 1, 2, 3, -1. All right. Would you plot the point then? -3, -1. Okay, next point. 1, 2, what would the inverse be? Flip it around, it should be 2, 1. And 5, 1, if we flip that around, would go to 1, 5. Okay, so I'm gonna then connect those dots. So this 4, -5 goes to here. Okay, so it's like this segment right here is flipped over the line y equals x. And from that point, it's gonna go to the point 2, 1, so right here. And then finally, it's going to go up to the point. This was 1, 5. Okay, I know it kind of looks messy. But now what I'm going to do is I'm going to draw for you guys the line y equals x. The line y equals x is the line where every x and y coordinate is the same. So 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. I'm going to draw it as a dashed line. You do the same. Okay, it goes right through the middle. Now, hopefully what you guys see is if you would flip that black graph across that line, because I reversed the x and y's around, it is a reflection of about that x equals y line. Okay, so that's what it looks like. Okay, looking at the purple graph, I don't know if you can see the purple graph. I'll highlight it because there's a lot going on there. Does the purple graph pass the vertical line test? Does the purple graph, my purple graph, I know yours isn't purple, does it pass the vertical line test? What about right there? Do you see it hits more than once? Yes? Do you see right here it hits more than once, the vertical line? So it does not pass the vertical line test. Is the inverse a function? That is a no. Okay. So that's what an inverse is. Now, so we talked about tables, switch them around, graphs, switch them around. Let's talk about equations. First of all, you're going to see a notation you have never seen before. And the notation that you're going to see is this one. It's f negative 1 of x. And the way I'm going to read it, though, when I see that, is I'm not going to write f negative 1 of x. I'm going to say f inverse of x, or the inverse of f of x. Okay? What happens with an inverse function, here's where the composition comes into play. If you would put, once with the equation, if you would put the equation into its inverse and simplify it, what you're going to always get back 100% of the time is the value x. That's exactly how it works, both directions. Okay. So in an equation, if you put the function into its inverse, like we were doing yesterday, and you simplify it, you always get an x back. Okay. Finally, if you are wanting to check if a inverse is a function, you can use the horizontal line test. And you're going to use that on the original to see if its inverse is a function. The other option I tell students is you could always graph the inverse like we did above and use the vertical line test. Okay, let's do a couple more on the back. So what we're going to do is we are going to find equations now. We're going to write the original function, but instead of an f of x, we're going to write the letter y there. Y and f of x mean the same thing. Next, you are going to switch the x and y around. That's going to be the inverse part. Solve for y using inverse operations. And finally, you're going to replace y with f inverse of x. So I'm going to just do one with you. And then you're going to try one. I'll talk about domain and range at the end. Let's just do our steps. Okay. Do you see how this is already written as y? So I don't need to do step 1. So we just have y equals 1/2 x plus 1. Okay, that's step 1. 2, switch the x and y around. Okay, instead of y, what am I going to put here? X equals 1/2. Instead of x, I put y. Okay, now that's now the inverse. I just switched the x and y around. Last step, though, I'm going to solve for y using inverse operations. What I mean by that is, how do you undo addition? Subtraction. Then x minus 5 equals 1/2 y. How do I undo multiplying by 1/2, or think of it as dividing by 2? Wouldn't you multiply both sides by 2? So I have 2x minus 10 equals y. And then last step, I just replace the y with an f inverse. 2x minus 10 equals f inverse of x. Okay. So that's where we're going to stop for today, and now I want you to try one on your own. So when you get this paper, would you flip it to the back? Okay, so what I would like you to try is question 9. It's y equals 3/8 x plus 5. Can you try that for me?